Welcome back. Let's continue with our calculations. So let us now look at division using the long division method. So now I have here 320 divided by 5. To make this easier for us, we are going to use our clue board. So our clue board is just going to help us to make these calculations easier, because now we need to find out how many groups of 5 are in 320. So we are going to look at the multiples of 5. We know that 5 multiplied by 2 gives us 10. We know that 5 multiplied by 6 gives us 30. 5 multiplied by 100 gives us 500. But then now that is too much. The other numbers were too low. That one was too high. So we need to go back. If I look at 5 multiplied by 6, we said there it was 30. But if I say 5 multiplied by 60, that one will give me 300. So I think I can work with that. So 5 multiplied by 60 is 300. We did multiply by 60, so I am going to place a 6 in the tens column. So now we have found that we can take out 60 groups of 5 in 320. So 60 multiplied by 5, that will give us a 300. The next step is to subtract. 320 minus 300 leaves us with just 20. Next, we need to know how many groups of 5 we can take out of 20, but we already know that we can take out 4 groups of 5 in 20. So only 4, that is a 1. I'm going to place the 4 in the ones column. 4 multiplied by 5 is 20. 20 minus 20 is 0. And then we can see here that there is no remainder. That means that 320 divided by 5 is 64. I hope you understood that, and I hope that the clue board made it easier for you to understand. Let's look at a second one. So now we have here 7,390 divided by 10. Again, we are going to use our clue board. This time we are looking at multiples of 10, and we need a number that we are going to multiply by 10 so that it brings us very close to 7,390. So let's look at 10 times. We are dealing with 7,000, so I'm going to go higher. So let's look at 10 times 100. That gives us 1,000. Let's go higher, 10 times maybe 700, and we know that that gives us 7,000. So 7,000 is close enough to 7,390. So we are just going to use 7,000. Because we multiplied by 700, we need to place the 7 in the hundreds column. So 700 multiplied by 10 gives us 7,000. We are going to subtract that. Let me just write those properly in the columns. Then we have 7,390 minus 7,000, which gives us 390. Now again, we are going to repeat. We need to know how many groups of 10 can we take from 390. Now again, the clue board, 10 multiplied by 3 is 30. But then 10 multiplied by 30 can give us 300. I think that's close enough. We can use that. So because we multiplied by a 30, we are going to place the 3 in the tens column. So 30 multiplied by 10 is 300. We are going to subtract. 390 minus 300 gives us 90. And then how many groups of 10 can we take out of 90? That's an easy one. It is 9 groups of 10. 9 multiplied by 10 is 90. When we subtract 90 with 90, it gives us 0. That means that 7,390 divided by 10 is 739. I hope you understood that well. Let's move on. So let's look at 231 plus 244. So with rounding off and compensation, we are going to start with rounding off these numbers to the nearest 10. So now 231 rounded off to the nearest 10 is 230. And 244 rounded off to the nearest 10 is 240. So because we have taken away 1 from the 231 and taken away 4 from the 244, we are first going to add these rounded off answers, and now I have 230 plus 240, that gives me 470. That's when I have rounded them off. But now, because I've taken away 1 and I've taken away 4, I need to add them back. That means now with 231 plus 244, I am going to have the 270 plus the 1 plus the 4. And my final answer is going to be 475. Let us move on. So the next section that we are going to look at now is calculating with whole numbers. So that is to perform multiple operations on whole numbers with or without brackets. So this next example is an example of multiple operations with or without brackets. So let's calculate the following without the use of a calculator. I have there 7 plus 6 open bracket, 15 minus 10 close bracket, divided by 3 minus 5. So remember, when we are working with multiple operations, we need to work on either side of the addition or the subtraction. So now that means here, because we can see there is an addition and there is a subtraction there, this one in the middle is one number because it is combined by multiplication and division. So now when I am calculating this, I am first going to start with either sides of the addition and subtraction. So that means I have 7 plus, and then we have 6, and in the bracket 15 minus 10 is 5. Then we divide by 3 and we minus 5. So I still have the 7, and 6 multiplied by 5 is 30. We are going to divide that by 3 and we are going to subtract the 5. Remember, we're still working on either sides of the addition and subtraction. That means I have there 7 plus, now 30 divided by 3 is 10. And then we are going to minus the 5. Then I have 7 plus 10, which is 17, minus 5, and our final answer there, 17 minus 5, is going to be 12. Let's move on to the next one. Now, the next one is 9 minus 2 open bracket, 5 minus 3 close bracket, plus 6 divided by 2 plus 4 times 2. Now remember to work on either sides of the addition or the subtraction, just to work with those terms. So we have here 9 minus, and I'm going to calculate that term there, which is 2, and then in the bracket it's 5 minus 3, which is 2. Then we have 6 divided by 2, which gives me 3. And we have 4 times 2, which gives me 8. Our next step will be to calculate that 2 times 2, which is 4, plus 3, plus 8. Then we have the 9 minus 4, which gives us 5, plus 3, plus 8. That is going to give us a total of 16. So our final answer here is 16. Let's move on to our third part, which is the multiples and factors. Let's quickly remind each other how to get the multiples. Remember, multiple is the product of two natural numbers. So the multiples of 8 are 8, 16, 24, 32, and you can continue with that. Then the multiples of 12 are 12, 24, 36, 48, and I think you can continue with that as well. The reason why I'm stopping is that already I've realized a common one. Remember, we are trying to find here the lowest common multiple. So a common one, the first one that comes up as common is the 24. This means that our LCM is 24. So now we are going to find the LCM and the HCF using prime factorization. Let's start with the lowest common multiple. So remember, when we are working with prime factorization, we need to write the numbers that we are working with as the product of their prime factors. Now, if you remember, a prime number is a number that only has one and itself as factors. And I've got the first few prime numbers listed for you there so that you don't forget them. Now, a prime factor would be a number that is a prime number but is also a factor of that number. Let's use this method to find the lowest common, to write 8 as the prime factors. So I have 8 there, and I am going to divide the 8 by 2. Now I'm dividing by 2 because that's the first prime number. So I'm going to divide by 2, and the answer there is 4. And when I take that 4 and I divide it by 2 again, the answer is going to be 2. And I continue dividing by 2 because it is still divisible, and my answer is going to be 1. This means that if I write 8 as a product of its prime factors, then this is going to be 2 multiplied by 2 multiplied by 2. So 8 is equals to 2 multiplied by 2 multiplied by 2. Then we have 12. So in the same way, I'm going to start with the first prime number, and I'm going to divide by the 2 from 12 here. So we have 12, and I'm going to divide that by 2, and my answer is going to be a 6. Now, I'm still going to divide by 2 because 2 is still divisible, and when I divide the 6 by 2, the answer there is 3. Now, I would continue with dividing by 2, but 3 is not divisible by 2. So I'm going to move on to the next prime number, and that is going to be our 3. So when I say 3 divided by 3, that is going to give me a 1 as an answer. It means that 12 is equals to 2 multiplied by 2 multiplied by 3. As you can see, I am taking those prime numbers that I was dividing by. So now, how do we find the lowest common multiple using prime factorization? We need to look at all the factors that we have used here. So we have used 2 as a factor, and we have used 3 as a factor. So we are not going to repeat the factor that we have used here. So I'm going to first list the factors that I have used, and that is a 2 and a 3. But before I can come to my final answer of the lowest common multiple, I need to look at each number and choose the factor with the highest frequency. Now remember, frequency just means how often a number appears. So I am going to look at the list from 8, which is 2 multiplied by 2 multiplied by 2. Now in this list, 2 appears 3 times. And then I am going to go and look at the list of 12, and 12 is equals to 2 multiplied by 2 multiplied by 3. And here our 2 appears 2 times only. So we want where it appears the highest frequency, and that is 3 times. So that means I am going to write it out 3 times. And then I'm going to look at the 3. When I look over at the 8, 3 is not there as a factor. And when I look at the 12, 3 is there as a factor. And the highest frequency that it appears there is only once. So that means I am just going to multiply by 3 and only 1 3. So what is my lowest common multiple? That is going to be 2 multiplied by 2 multiplied by 2 multiplied by 3. If you multiply that, 2 multiplied by 2 is going to be 4. We multiply that by another 2, that is going to be 8. And when we multiply the 8 by 3, the answer there is going to be 24. Let's move on to the factors. So a factor is a number that divides exactly into a whole number with no remainder. Let's quickly list the factors of 8 there. 1, 2, 4, and 8. And the factors of 12 are 1, 2, 3, 4, 6, and 12. So which one is the highest common factor here? We can see that there are a few common ones, but the highest one, but the highest one there is 4. So our highest common factor is 4. But how would we find this 4 using prime factorization? Now, we've already written our 8 and our 12 using our prime numbers. Then, how do we find the highest common factor? With this one, we are going to look for the common factors only. So the common factors here is only the 2. But this time, we are looking for the one where the least 2's appear. So remember, with the lowest common factor, we took where the highest number of 2's appear. So now we are taking the lowest number of 2's where it appears. We've got 3 of them on the 8 and we've got 2 of them on the 12. So we are just going to take the 2 that appear, which is 2 times 2, and our answer is 4. Can you see that it's the same way that we used, we found the highest common factor? But what about when we are dealing with bigger numbers? We can still use the same method. So let's end our lesson with finding the LCM and the HCF between 240 and 216. So let's start by writing each of the numbers as their prime factors. We are going to say 240 divided by 2, that gives us 120. We divide by 2, that is 60. We divide by 2, gives us 30. Divide by 2, gives us 15. Now we want to divide by 2, but because 15 is not divisible by 2, we move on to the next prime number, which is 3. So 15 divided by 3 is 5. And then again, 5 is not divisible by 3, so we move on to the next prime number, which is 5. And 5 divided by 5 is 1. When you get to 1, you know that you are finished. So how do we present 240? As the prime factors, we are going to say 2 times 2 times 2 times 2 times 3 times 5. So that's how we represent 240. Let's do the same for 216. 216 divided by 2 is 108. 108 divided by 2 is 54. If we divide that by 2, it's 27. Now, because 27, it is not divisible by 2, we move on to the next prime number, which is 3. 27 divided by 3 is 9. Divided by 3 is 3. And then 3 divided by 3, that is 1. When we get to 1, we know that we are finished. So 216 can be represented as 2 times 2 times 2 times 3 times 3 times 3. Okay, so how do we find the HCF? Do you remember how we find the highest common factor here? So the highest common factor is found by us looking for the common factors. The common prime numbers. So the common ones here are 2 and 3. So we have 2 and 3 for 240. We have 2 and 3 for 216. But remember, we are going to look for the one with the lowest frequency. So the one that appears the least. Let's start with the 2. On this side, we've got 1, 2, 3, 4 2's. And on this side, we've got 1, 2, 3 2's. So that is the lowest frequency, 2 times 2 times 2. There's only 3 of them. And then the other common one was the 3. On this side, we've got 1 3, and on this side, we've got 3 3's. So the lowest frequency is just the 1 3. So what is the highest common factor here? 2 times 2 is 4, times 2 is 8, times 3 is 24. It means that the highest common factor between 240 and 216 is 24. Now remember, learners, frequency is how often a factor appears. Lastly, let us find the lowest common multiple. So the lowest common multiple, we've already written our numbers as their prime factors. Now, how do we find the lowest common multiple again? We are going to look at every factor, the 2, the 3, and the 5. And then we are going to take the one with the highest frequency. So this side, we said it has 1, 2, 3, 4 2's. And this side, it has 1, 2, 3 2's. So the highest frequency is the 4 2's. 2 times 2 times 2 times 2. Then we are going to look at the 3. There's 1 3 this side. There's 3 3's this side. So the ones with the highest frequency are the 3 3's. And lastly, we are going to multiply with the 5. There's 1 5 here. There's no 5 there. So we are going to take just the 1 5. And when we multiply all of those numbers together, our answer is 2,160. So that was our lesson for today. I really hope you enjoyed it as much as I did. We'll see you next time. Goodbye.